Let me get this back on.
Advisory committee for this Bahamas Protected project, and we are joined online by a number of other people who are interested in this research from the Bahamas and elsewhere. And we look forward to hearing from Dr. Katie Arkema, Catherine Wyatt, and also incorporating research that was done by Dave Fisher, all from the Natural Capital Project. So marine and coastal environments provide numerous benefits to Bahamians, but these areas are under threat through a growing intensity of activities. The Bahamas has embarked on an ambitious goal of protecting 20% of our marine and coastal habitats by the year 2020. And we're doing a lot of work thinking about sustainable financing for this network of protected areas. But one component is better quantifying the value of our network of protected areas, both our existing network and thinking about going forward. So
Katrina, are you there? I can't hear you anymore.
can you hear me now?
Yeah.
Okay. Okay, so I'm really excited to be able to share the research that you've done, building on other work that the Natural Capital Project has done here in the Bahamas, and other researchers such as Venetia Hargreaves-Allen, who've done a lot of economic work looking at the marine and coastal resources of the Bahamas.
Great, thanks for that introduction. Yeah, I am communicating with Katie. I think she's just trying to share her slides now. Just a second. Katie's just joining now, but in the meantime, I just wanted to say that it's so great to have so many voices on the phone, so much interest in this project. There's such a wealth of research in the Bahamas, and it's great to see such great communication between individuals and organizations and ministries. So thank you all for being here today. And I see that Alicia asked in the chat window, this webinar is being recorded, so you will receive a recording of this for future reference, and you are being recorded, so if you don't wish to be recorded, you don't need to say anything. You can either, I think you can raise your hand, or you can use the chat window to ask a question, and you can specify whether you'd like your chat to go to everybody or just a particular person.
Morning, this is Katie. Can you see my screen, Katerina?
Not yet.
Oh, sorry, no, we can't see it yet.
Is that working now?
Yeah,
Yep,
that's great.
Okay, and it's just the slide, Catherine, in presenter mode. That looks good.
Yep.
Okay. Okay, great. Good morning, everybody. My name is Katie Arkema, and I'm a lead scientist with the Natural Capital Project. And I believe I've met many of you, and those that I haven't, I look forward to hopefully getting to meet and speak with you sometime in the future. And I wanted to thank Katerina and Marcia and others for giving us this time today to share some of the work that we've been doing in support of the Caribbean Challenge Initiative in the Bahamas. So this work is collaboration with my colleagues, Dave Fisher and Catherine Wyatt, and builds on some of the work that we did in collaboration with the Office of the Prime Minister, the University of the Bahamas, the Inter-American Development Bank, excuse me, the Nature Conservancy, and others on Andros to support the Sustainable Development Master Plan there several years ago. Okay, let's see. So by way of a little bit of an introduction, as I think we are probably all aware on the phone today, that people conduct a variety of different activities in coastal and ocean environments. And traditionally, the sort of perspective towards management has been focusing on the negative and top-down impacts that people have on the environment. And in recent years, there's been growing interest in the benefits that nature provides to people. So not just thinking about the negative impacts, but also accounting for the positive effects of ecosystems on things like food security, fresh water, coastal protection from storms, and a whole host of different goods and services. And the idea is that if we can close this loop between people and the environment and account for not only the ways in which people affect ecosystems, but also how changes in ecosystems in turn affect people, we may be able to reach a broader set of stakeholders outside a traditional environmental community. And this broader set of stakeholders would be development banks, central governments, private sector, and in that way be able to direct investments and planning and decision making so that we can both promote protection of the environment, economic development, and human well-being at the same time. And this is really what we work on at the Natural Capital Project, is understanding these relationships between people and the environment. And so in our work in support of the Caribbean Challenge Initiative, we've been, earlier this year, we were hired to support BRIEF, the Nature Conservancy, the Bahamas National Trust, and others in understanding better this, especially the economic value of these ecosystem services within Bahamian marine protected areas. And so here in this slide, you'll see a map that we created with input from all of our collaborators to be able to locate and show where the current network of protected areas is in the Bahamas, and also the sort of extent to which these different areas and different sites have draft and finalized management plans. Because really the goal of the Caribbean Challenge Initiative more broadly, but in particular, or one of the goals, and in particular this work with economic valuation of protected areas, is to be able to help highlight the importance of managing the existing sites and managing any future designated sites in order to achieve these economic and human well-being benefits. So I believe that as of November, 4 out of the 40 existing sites have finalized plans and 15 have draft plans, and there's a lot more effort going into expanding that set of finalized plans. And so as a part of our work earlier this year, we worked with our collaborators and partners to identify what would be most helpful, what could the Natural Capital Project bring to this process. And we identified three contributions that this work could make. So reviewing the past studies of economic value of marine ecosystem species and within MPAs, helping to use this work to make the economic case and build awareness and support for MPA declaration by quantifying the economic value of ecosystem services within the existing network, and exploring some of the management issues and values of ecosystem services at sort of what we called our deep dive sites. So these were 5 island scale analyses where we looked at values of ecosystem services within MPAs under various management regimes. And so this is really the outline for the talk. And I know we only have about 45 minutes, and I wanted to include a little time for questions. So we're just going to go briefly over some parts of this. In particular, the review of past studies. I've got just a couple slides here. Really, we wanted to make sure to look at this past work because there is a wealth of information that has been collected and analyzed in the Bahamas about both the values of habitats in particular. So you see here ranges of values per kilometer squared for coral reefs, mangroves, and wetlands, tidal creeks, and seagrass. And we have a database that we've compiled of all the peer-reviewed and gray literature that went into these ranges here. And in addition, this sort of helps us understand what kind of information is out there that we can feed into our models, which will come up later on in this talk. And we can use this as sort of a jumping off block to then be able to ask, well, how would these values of these habitats actually differ in space? So these are sort of ranges for this each kilometer squared, but we know that variation in biophysical conditions and in social and economic factors influences the demand and the value for these ecosystem services provided by these habitats. We also reviewed the literature to ask what past studies exist about sort of by ecosystem service. So the previous slide was looking at by habitat contribution to ecosystem services. You can also look at by ecosystem services such as fisheries contributions, tourism, and coastal protection. And one of the things that jumped out at our review is that, there's been a lot of focus on tourism and fisheries, but there's actually a whole suite of services that are provided by ecosystems within MPAs, including, for example, coastal protection from storms and sea level rise. And so there's opportunities to expand the types of services that are quantified within the Marine Protected Area Network and beyond. And then also opportunities to look at, use models to understand, well, how would these values change in the future? So that brings us to our second part of the talk. And that's revolves around using something called production function models. And what these models do is they allow us to sort of forecast, in a sense, if we make changes in ecosystems or changes in ecosystems result from the management actions that we take around, say, siting coastal development, investment in infrastructure, things that affect pollution, all those kinds of factors can influence the extent and the quality of ecosystems. These models then allow us to see, well, how does that change the services that are provided and the benefits that people derive from those services? And at NatCap, we've been building over the last 10 years a set of software that we call INVEST, which stands for Integrated Valuation of Ecosystem Services and Trade-offs. This is open source. It's all software that's available to anybody to download and to use to shed some light on benefits to people from ecosystems in a variety of planning and decision-making processes. So for the second part of our work, we use these models to sort of understand what the economic value is of the existing of ecosystem services within the existing network. And we did that by focusing on, oh, excuse me, let me step back for just a moment. Just to give you a little bit more information about this production function approach, it's actually sort of analogous to the production function approach that's used in strictly economic calculations, say, of sort of the relationship between social capital or financial capital and outputs. Manufacturing, for example, you have to think about what sort of infrastructure and what sort of capacity go into the system, and that tells you what kind of products will come out. So we can do the same thing with ecosystem services. And on the top line here is the general conceptual model where we can articulate an action that's taken, such as, say, implementing a rain protected area, understand what the change in ecosystem structure and function, so what types of habitats and what sort of processes do they do, like reducing waves or providing habitat for baby lobster. How does that then affect the services we get, like the catch of lobster or a reduction in flooding or erosion? And then how does that then influence societal benefit? And those values can be in economic units. It can also be in human well-being units. And so here, down at the bottom, we've applied that to a mangrove restoration action. And extending the width of mangroves along the shoreline can influence the hydrodynamic conditions, influence flooding and erosion, affect the damages to coastal infrastructure. So we apply this sort of ecosystem services assessment that includes this production function to each of 4 ecosystem service models. And when we work in any project with partners that are trying to use this kind of science to inform decisions, we spend a while trying to figure out what are the most sort of relevant ecosystem services to assess. And this has to do with what are those services that are going to resonate with stakeholders, what are the ones that we have some data on to access. In a project that was a short timeline like this one, that was several months, we need to think about what models do we have available. Sometimes if we work on a project for several years and we have some extensive funding, we can develop new models and then integrate those into the software if there are new sort of services that people want to assess that we don't have models for. So these 4 ecosystem services are ones that we've seen in our work throughout the Caribbean, are particularly powerful for understanding how management decisions can then influence benefits that are provided by these ecosystems to people. So these are the 4 that we assessed during this project. And now I'm going to show you several slides for each one of these services. And for each service, there's 2 to 3 slides. And the first one is a very simple list of the inputs and the outputs for the model. So this gives you an idea of the kinds of data that went into the analysis and what kind of metrics we produced in terms of outputs. Also gives you a sense of sort of opportunities for collecting and improving these kinds of input data. And there's a whole lot of math and a whole lot of code, computer code that's behind these models, but I don't have time to get into those technical details today, but it's something that Catherine and Dave and I would be happy to answer more questions on if anybody's interested in having a follow-up Skype call. I'm sure, I have no doubt we can find time to do that. So for the ecosystem service of spiny lobster, what we did is we quantified the economic contribution of the nursery habitat to the outputs of in terms of catch of spiny lobster in pounds. So that would be a biophysical metric. The revenue associated with that catch by incorporating data on export value, and the value of mangroves and seagrass to that catch and revenue. And I think one thing that's really key to indicate here is we have data on mangrove distribution and seagrass distribution. That those data could always be better. So if we had better idea of what the density was of these habitats across the region, that kind of information could be incorporated into the models. Another big issue is that these aren't the only habitats that matter for early life stages of lobster. So some of the red algae are really important along the coast and the freshwater creeks. And so the models are flexible enough where if we can collect those data, we can actually put them into the model. But it's, of course, very difficult and requires resources to do that data collection. So with these models and input data, we're able to look at where the proportion of the region's nursery habitat in terms of mangrove and seagrass, where that lies in relation to the entire marine protected area network. So you see here the proportion for each MPA, and it says proportion of the region, and the region's on that first column. And what this model does is it helps us take into account the fact that lobster move between their early life stage habitat to their adult stage when they're caught. And they are going to move over these shallow water areas. So essentially there's sort of different nursery habitats in different regions that contribute to the adult lobster. So we can look to see which of these MPAs is contributing a large proportion of the region's nursery habitat. And then from there we can look at, and I apologize here, it looks like the top of the column title is cut off. So we'll make sure to get that in the final presentation. But what these columns say are essentially the contribution of nursery habitat in MPAs in these regions to the catch in terms of millions of pounds and revenue in terms of millions of dollars. And so this helps us get a sense of like the importance of these habitats, the economic value of these habitats to this important fishery. And it also helps us understand what the sort of contribution of different regions and the contribution of MPAs within those regions. And that helps inform planning. We can sort of think about how to allocate resources to management and where we need to make sure to be doing a particularly good a job to site new development so it doesn't affect these nursery habitats. Okay, and so the second service is tourism, and similarly set up slide here where we have inputs of the tourism model and the outputs. And one of the powerful things about our tourism approach is that it's very difficult to know where people, tourists and visitors are going within a particular region. So we have really important survey data that's being collected by the Ministry of Tourism that tells us about what islands people are going to, how long they're staying there, whether they're cruise or stopover visitors. All that data is really important for feeding into this analysis. But what it doesn't tell us is where people are going on sort of from 1 kilometer, 1 mile to the next. And we need to understand that fine scale distribution to be able to forecast how changes in ecosystems are going to affect where people go. So that's really what we did with this analysis is we say, okay, what if we were to lose some of the sort of ecosystems within these MPAs? How would that influence visitation? And so what we can look at here is we can use these social media data to understand where visitors are going across the landscape. And this is a data set we have from Flickr for 10 years of visitation across the globe. And that's just, we've done this with Twitter and with other kinds of social media as well. This is just a particularly good data set for global coverage. And then we can use it. Here's a zoom in here where the yellow is all of these geotagged photos. So it gives us the relative visitation to different regions across the Bahamas and different MPAs in particular. So in the blue lines are the outlines of the MPAs. And in the bar graph here, you can see for each MPA, we combined this information about relative visitation, so the proportion of the total visitation to each one of these MPAs. We combined it with Ministry of Tourism data of total numbers to different islands and to different regions. And that gives us this metric of annual visitor days that you see on this bar graph here by protected area, and in gray are those cruise ship visits. So this again gives us an idea about the distribution of visitation to different MPAs and also in the expenditures that are associated with each of these sites. Okay, so now on to coastal protection related services. And again, we've got models that take into account differences in important factors like the way the shoreline type and geomorphology, how rocky or sandy or muddy a coastal habitat is, or sorry, a coastline is. Different habitats like coral reefs, mangroves, seagrass, coppice forest that can all have an influence on waves and on storm surge. Take information on wind exposure, wave exposure, an indicator of storm surge, which is the distance of the continental shelf, and several other factors to understand what areas are most exposed to coastal hazards. And in particular, the thing that we're interested in here for this, for the understanding the importance and the value of ecosystems within MPAs is to understand, well, now what if we were to lose those habitats that are in MPAs because it wasn't well managed for? So we can use the model to essentially test, what if those habitats were lost? How would that then influence exposure of coastal populations? And that's this table here. So again, we've got some island groups. We've got the list of current MPAs associated with each of these island groups. And then we can use the model to understand the reduction in exposure. So you can think about this as a measure of protection provided by these coastal ecosystems within MPAs. And this is in terms of millions of annual income. So we used the census data and information about annual income as a proxy for value of these ecosystems for reduction in exposure. And then we can also look at numbers of people that are benefiting in those island groups from reduction in exposure due to coral reefs, mangroves, seagrass, and coppice forest. And lastly, carbon storage and sequestration. And this model takes into account, again, maps of coastal habitats that can store and sequester carbon, and mangroves and seagrass do that not only in their above ground biomass, but also in the soil and the below ground biomass. And we can take information from the literature about variation in this storage across different regions to parameterize those models. And then information about social value of avoided carbon emissions. And the model will produce these types of outputs here on the right, including carbon storage, accumulation, and net sequestration and present value. Now for this study here, we particularly looked at millions of tons of stored carbon across the existing network. And so on the left-hand side is for each one of the MPAs. And of course, the size of the MPA is often related to the amount of these habitats within the MPA. And so on the right is carbon storage per kilometer squared. And one of the things that really influences the extent to which these MPAs sequester carbon has to do with the relative abundance of seagrass and mangroves, because different habitats store and sequester different amounts of carbon in their biomass and in their soils. And so this is a good example of an analysis that could be improved even further by greater data. So if we can do I know there's been a couple of studies in the Bahamas, but if we can invest even more in empirical work out in the field, conducted either by scientists at the University of the Bahamas or by the various agencies like Department of Forestry and others, we can get a better sense of how much is actually being stored in different habitat types. And then we can also use that social value of stored carbon to quantify the value of avoided emissions. So this table here just summarizes those results for the 4 services in terms of the total contribution in both economic and sort of additional metrics, so biophysical or numbers of people, human well-being metrics, for the network as a whole. And then on the right gives you a sense of some of the factors that influence that spatial variation. So if you remember way back in the beginning where we talked about reviewing past studies and how that information all laid the groundwork for a lot of this work. And then one of the things that this work can do is help to say, okay, we know that we don't have a constant value for each of these habitat types and each of these services, but they actually vary in space. And the models that account for these different factors on the right-hand side help us understand how that spatial variation occurs. So how different MPAs contribute different amounts of these services. Okay, and so our last part was that we wanted to try to get a little bit more into how different kinds of management decisions could influence the economic value of ecosystem services within MPAs. And we also wanted to touch upon the fact that each island and each MPA has is sort of set in really different contexts with different social factors and economic factors. So we thought that by identifying a few places that we could dive in a little more deeply, we could help to illustrate some of these important considerations. So Exuma is, of course, a really well-studied MPA, and it's the longest and certainly the sort of factor of the no-take areas within the Bahamas has been really important. So we wanted to be able to add some additional information about these services within Exuma. And so you can see on the top left there shows habitat, what habitats within the park are providing important reduction and coastal hazards related to wave attenuation and flooding. And also just other MPAs in the region that are more closely associated in space with communities that could benefit from that avoided coastal hazard impact. And then on the top right-hand side shows a distribution of photos from the social media data and that reflect variation in visitation by tourists to the region, along with dive sites, cruise ports, and airports, because certainly visitation is influenced not only by the extent and the health of ecosystems and nature, but also by infrastructure that supports tourism. And then down on the bottom, we have carbon storage, showing spatial variation within and outside the protected area where mangroves and seagrass contribute, and then the contribution of nursery habitat within the park to lobster catch outside of the park. We also zoomed in on Bimini because of the sort of interest in the North Bimini Marine Reserve, which has been approved but never officially gazetted, and wanted to shed some light on the importance of this area to coastal protection services from storms and sea level rise, and people on the island that are benefiting from reduction in waves and flooding. Contribution of the park and to visitation, to carbon storage, and then again the nursery habitat contribution to lobster catch from throughout the region. On Andros, we leveraged some of the scenarios that we'd developed as part of the Sustainable Development Master Plan, and used a risk assessment approach to be able to understand how different ecosystems, which you see in habitats, which you see pictured here, mangrove, beach, seagrass, and coral, to understand how these ecosystems are exposed and at risk of habitat degradation from all kinds of uses that go on Andros. So coastal development, roads, invasive species, climate change, sea level rise, transportation of goods and people. So all of these activities that are really important in the coastal zone can pose risks to ecosystems. We wanted to understand how that risk is distributed currently and also in the future. And so we used the set of different development scenarios that were derived from all the stakeholder engagement that Stacey Moultrie and Sev Consulting Group did throughout Andros to help to inform the design of what was ultimately the sustainable prosperity scenario for sustainable development of Andros. And what we decided to do with this work here to inform the MPA process is that we hadn't really focused in particular on MPAs as part of that Andros work. We included them in the analyses and the scenarios, but in this project here, we wanted to say, okay, well, focusing in on if these different scenarios were implemented and MPAs were managed in different ways, how could that then influence these different services? And so nursery habitats within the Andros MPAs, and there's several, contribute 3.5 million pounds in lobster catch. So it's not that the lobster are being caught there, it's that the model allows us to look at the importance of the Andros MPAs to the lobster catch from throughout that shallow shelf habitat region around Andros out onto the banks. And that's really powerful because that allows us to understand how would management locally in these MPAs and how would sustainable development on Andros, how does that influence the catch more broadly and the catch nationally. We also looked at Andros MPAs and used the approach to identify 113 million in visitor expenditure contributed to the MPAs, and then the influence of the master plan and the sustainable prosperity scenario on that increase in expenditure. So if the master plan is then including well-managed MPAs, how would that change? And then so on for the other services as well. I'm going to try to wrap up pretty shortly because I want to save a couple of minutes for questions. For the Southwest Marine Managed Area, this is one of the newest designated MPAs, and it's in a region that it relies on a number of different coastal and ocean sectors for economic development. And so we wanted to shed some light on interaction between effects that people can have on ecosystems and in turn how those ecosystems benefit people. And so we used a cumulative risk assessment approach again, where we identified a suite of different sectors and activities and used our GIS to be able to map these data to help us understand where they overlap with different habitats around Andros and how that can pose risk to those ecosystems and habitats. So in red are areas of greater risk, and in blue are areas of lower risk for a whole set of different habitat types. And you can see the Southwest Marine Managed Area. I think you might be able to see it most easily on that beach, the top left, where you can see it wraps around from the northern to the western side of the island and down. So part of this work is really about just helping raise awareness about where these MPAs are actually located and how different activities are occurring in and around them. If we have this information, we can make more informed decisions about how to manage these activities. We can also use this kind of analysis to be able to explore how coral restoration and restoration of other habitats could influence delivery of ecosystem services. So we did a little work where we identified some areas that have been considered for restoration and then fed that into the risk assessment model to see now if we actually restore these areas so they turn from red to blue, and we can use the service models to say how does that increase in coverage of the habitat and health of the habitat then influence services. And so those are the results here. And the main take-home messages are that we can use this risk assessment approach, and that's the results in the blue. We can use that to understand how, if we consider the potential degradation of these activities in and around the protected area, we can see how that actually reduces services compared to the no risk scenario at the bottom. So that's if we assume all of those habitats are pristine, we get a much better return on our services. And that helps us understand, we may never reach a pristine scenario, but we can certainly make improvements in our management. And so if we can figure out how to reduce some of the negative impacts of the activities by siting them in certain places or using best management practices, we can hopefully approach that better return from the current no risk scenario. We can also see how restoration can help improve the return of these services, depending on the scale. That's one of the things that's a little tricky, sort of a lot of detail to get into here, but restoration sometimes happens on a smaller scale, and so we need to invest significant resources in order to get it up to a large enough scale that can make a big impact. And we did that for several of the services here. And then we also did a ecosystem service assessment of Eleuthera. And even though there aren't any current MPAs here, we use this as an example of the way in which ecosystem service assessment can help to inform some future management. So we know that a lot of work has been done, for example, on Andros, both from Dr. Hargreaves-Allen, Venetia Hargreaves-Allen, and also from the Natural Capital Project and TNC and BNT and others. And so we wanted to illustrate about how we can expand this work from well-studied places like Exuma and Andros and other regions to additional islands like Eleuthera. And this can give us a sense of how different habitats across different regions of Eleuthera contribute to the delivery of these services. So just wrapping up, I've got a couple more slides here. In summary, from these island scale valuation work, we can see that specific MPAs show important values of ecosystem services, and then including human activities and a risk assessment approach can help highlight the potential gains of effective management. An ecosystem services approach can also be used to explore locations for future MPAs. There's important implications of these findings for marine protected area policy, planning, and management. And one of those is that the economic benefits are quite large, and also that they vary between locations. Another is that effective management is needed to maintain and grow this economic value. And so we can, I hope that this work, and I'm hopeful that this work, in addition to all the other work underneath this Caribbean Challenge Initiative can help to motivate the finalizing the draft management plans and developing further management plans for those that don't yet have them. And lastly, MPA planning and management can be a part, should be and can be a part of comprehensive efforts like national development planning, integrated coastal zone management, master planning, sustainable development master planning like we did on Andros. So we can sort of account for the location of MPAs, the ecosystems within MPAs, and MPA management as part of these larger integrated efforts. And understand how MPAs can contribute to the sustainable UN Sustainable Development Goals and other international commitments. And then I think this work helps lay the foundation for understanding possible future sites for protection under the Caribbean Challenge Initiative and the 20 by 20 Challenge. So with further analysis of potential sites for future MPA implementation, we could assess where ecosystems and MPAs contribute to economic development and human well-being. And we've often seen in our work, especially on Andros, but in other areas throughout the Caribbean and throughout the world, that iterating, so going back and forth between such ecosystem service valuation that we did here and on the ground stakeholder engagement can be useful in terms of generating local support and considering a larger suite of services beyond fisheries and tourism, which are traditionally considered an MPA work in order to enhance future sustainability of these networks. So with that, I'll stop and I'd be happy to answer a few questions.
Great, thank you very much, Katie. I have a question.
Maybe this.
A question from here, what was taken into consideration to calculate the avoided costs?
So is that under the coastal protection analysis?
Right.
Yeah. So that set of biophysical factors that I first showed on that earlier slide under inputs. So we use the biophysical factors to understand first the contribution of ecosystems. So I think initially when a lot of interest began to bubble up in the role that ecosystems can play in terms of being natural shields from storms, initially I think ecologists in particular thought that wherever you had those ecosystems, they played an important role. And that you could just take maps of those habitats and know where the services were provided. But that's actually not the case, because the importance of those ecosystems depends on other physical factors in the system. So variation in waves and wind, the shoreline type, however hard or soft substrate, where sea level rises. So first you need to understand that marginal influence of the ecosystem. So we use a hazard index for that. And then that gives us, we can use the model essentially as a way to test, what if we took the ecosystems out? What areas would experience an increase in exposure? So we run two different analyses, one with the ecosystems in the model, one without, and we look at what places experience a lot of change. And now the sort of like ideal approach to looking at avoided damages is to use something called depth damage functions, but those are not frequently available outside the US and Europe. They require data to be collected over several storms, very high resolution data about how different structures, for example, if a house has a basement or how many stories it has, how those structures respond to different depths of water. And then that you can use that in these models to then give you the avoided damage costs. But we didn't have that information for the Bahamas. And so what we did is we used, other thing that people often do as a proxy is they'll use, if they have any information about spatial variation in per capita GDP, and sort of a similar metric is annual income. So I would say this is an underestimate because certainly, this is using census data from the Bahamas. It's not considering like income or infrastructure related to tourism, for example. There's many other factors in here, but we can at least use maps of annual income to get a dollar value for those areas that are experiencing an increase in exposure due to that we experience increase in exposure due to that loss of habitats. And that gives us the sort of essentially a proxy and economic metrics for the protective value of ecosystems to particular areas. Hope that helped. Sorry that it's complicated. So there's a lot of details to go into.
Were there any social components that were taken into consideration? A lot of the mangroves and coral reefs are important socially to Bahamians. Were those included in the valuation assessment?
I didn't quite catch all of that. I heard mangroves are really important to the social value, but I wasn't. What was the example?
Was there a social component included in the assessment?
The question was there a social component included in the assessments?
Yeah, so I would say yes and no. What we were really tasked with was to produce results for these ecosystem services and economic metrics, but fundamentally a ecosystem service assessment gets you at some of the social components because a lot of the information that we had to use to get at the economic value is really about where people are and how they're benefiting. So just the fact that the services we looked at, the fact that we're looking at at a high value export fishery, looking at the social value of carbon storage and sequestration. So there's a lot of analysis that goes into how people benefit from regulating climate. The fact that livelihoods depend on tourism expenditures. So there's those components. We also looked at numbers of people in that coastal hazard analysis. So if you remember, I didn't just show that annual income, but I also showed numbers of people. And then related to that, we can look at different demographic groups. So groups of people that are within different economic status, for example. So there's some social pieces, but this is definitely not comprehensive. We found that you can go on and on and on and look at all sorts of different factors in these service assessments. And that can sometimes paralyze you. So I think it's really important to think about what are those social factors that we think matter most and that will resonate. And I'm sure there's some that we were not able to assess here that you have in mind that would make for a really good future analysis.
Thank you so much for a very interesting presentation. I wanted to ask, in terms of carbon stored in our habitats, can you tell us or give us some idea of its relevance in terms of the global market for carbon sequestration? And also, what would be the next steps if you would recommend that we look at that as a country for us to become a player if you think it's possible?
Yeah, that is a great question. We try to do some back of the envelope calculations related to contribution to the sort of global carbon market, but there's there's so much, it's such a dynamic area right now where there's so many new policies and players that are coming forward. And so I think, I think, we ended up not sort of including some of those initial back of the envelope analyses in here because we didn't feel like it was slightly outside of the scope of what we needed to do for this study, and it was going to take some more work. So I would say, for example, there's a meeting going on right now in Montreal. That's the CDB, Convention on CBD, Convention on Biological Diversity. And so I know that global carbon markets will be something that is discussed at that meeting. So some of these international conventions that are really trying to forward the role of ecosystems both in terms of climate, but also in contribution to biodiversity and ecosystem services. I might try to pursue, try to understand. I don't actually personally know who the Bahamas sends to those kinds of meetings, so I would probably try to make sure that was something that was on the radar of the leadership, maybe in some of the NGOs or in BNT. And then the private sector is obviously really interested in this, and I might not just think about outside of the country, but also within the Bahamas. What sort of, we call them mitigation banks, which you might be familiar with in the US, but those are tied to carbon markets. And I sort of wonder about if there's any interest yet from the private sector within the Bahamas in participating in some of these banking and mitigation schemes. So those are just a couple ideas. I have to admit that the carbon markets are not my personal area of research and expertise, but I would be happy. I'm not sure, I don't recognize everybody's voices. I'm not sure who that was, but I'd be happy to follow up with some further ideas and connect with some colleagues on that.
Thank you.
Katie, it looks like we have a raised hand from Peter Hoagland. Peter, do you want to go ahead? Sorry, Porter, not Peter.
Yep. Yes, I'm Katie. I'm at the Marine Policy Center at the Woods Hole Oceanographic Institution, and very interested in this work. I think you and your group have done a really nice job on this. And one reason I'm interested is because in the spring I'll be helping to teach a course at Sea Education Association, which is a undergraduate semester at sea program. And those students spend some time in the Caribbean. And the focus of the course is on marine biodiversity conservation. But I would like to work in some ecosystem service aspects into the course, and hoping that I could either rely upon a report, if you have one, or maybe part or all of your presentation to introduce this to the students. And so I'm very happy that you've done this work.
That's wonderful, Porter. Thank you so much for your positive remarks and interest. And we'd be happy to, I know that Katerina is going to share this presentation and the report broadly. So we'd be happy for you to use any of this material in your educational endeavors. And then also, we have a extensive training program at NatCap because we obviously can't respond to all of the interest in this kind of work. And so we really try to build capacity of our partners and of our collaborators. So we have several different training opportunities, and you might be able to leverage some of that. Like we've got an online course you could share with your students to give them an introduction in ecosystem services. And then also I'm thinking in particular in our work with the Office of the Prime Minister and the Inter-American Development Bank for the Andros project and some coastal hazard work, we actually have some websites where you can explore some of the results. So it's not just sort of like static figures and graphics, but especially for the coastal protection work. And we have some exercises we've developed that help people understand how you can use this kind of information to inform some decisions. So do feel free to reach out to Catherine and Dave and me, and we can send you some of that material.
Okay, that would be great.
Great. And sorry, I think we're out of time at this end, but thank you so much, Katie and your team, for a really informative presentation. This is great information to have as we move forward with our protected areas in the Bahamas. And as we think about the other side of how much it costs to manage these, it's really useful to have at our fingertips some economic values of the benefits of some of these ecosystem services. So thank you so much. We will be sharing the final report and the summary document along with slides and the recording of the webinar to everybody who is listening in and here now. So thank you so much.
Wonderful. Thank you very much, Kazrina. Thank you, everybody, for attending, and I hope to follow up with many of you soon.
Great. Thank you.
Take care.
Thank you.